Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for the weekend of December 16th. I got to warn you, this one's going to be a little bit longer than normal. I'm going to do 2 lessons in one because we lost a little bit of time. So especially if you were taking the midterm and missed class this morning, you need to watch this a couple of times. All right, quickly, we're going to review how to solve a system just for the people that weren't in class today. If you were in class, you can just kind of pay attention. But if you weren't in class, please, please, please take notes and do it along with me. Let's say we have a system that looks like this. We have y is greater than 1/2 x plus 5. And then the other inequality will be like, 2x plus 3y is less than 6. Okay. For the first one, I will plot my y-intercept. Remember, I pretend that these say equals in terms of graphing. I pretend that there's an equal sign here and here. There really isn't an equal sign there, and my graph will look different when there isn't, but for the graphing purposes, I pretend it says equals. So this top one is in slope y-intercept form. I will plot the y-intercept, 1, 2, 3, 4, 5, right there. My slope is 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Now I go to draw my line, I have to decide, is it a broken line or a solid line? Hopefully you know that it is a broken line because there's no equal sign in it, right? So I'll put my arrowhead on. I'll do that. And I guess I can leave that black. And that'll work pretty good. All right, now, because it's inequality, I have to decide where to shade. Let me get my shading tools out. There we go. All right, mentally, I'm going to plug 0 in for y and 0 in for x. When I do that, I get the statement 0 is greater than 5. I know that is a false statement. Therefore, I will not shade where the origin is. Oh, I moved out of shading mode. Silly Mr. Lawrence. So I will shade up here. All right. Now, this one is in standard form, the red one. So I'll find, this is an easy one to find the intercepts on. I think I'll find the intercepts. The x-intercept is going to be c divided by a, so that's going to end up being the 0.30 because 6 divided by 2 is 3. The y-intercept, which will be c divided by b, is going to be 0, 2. So I will plot the point 1, 2, 3, 0 and the point 0, 2. And I can tell that my slope is up 2, back 3, up 2, back 1, 2, 3. And that looks good. I can draw a line. This will also be a broken line. And let me see here, down to 1, 2, 3. All right, I like that. I'll change some properties on my line here. Now, it's very, very important that you note my lines, I need to take up a good portion of the graph. I need to take up as much of the graph as is required to show where they intersect if they do. Okay, so please don't make your line short. Please use straight edges to draw your lines. All right, now I'm going to go ahead and shade. And I think I'll use blue this time. I love to do this on my smartboard. And so I think I'm in highlight mode. Yes, I am. Good. All right. I need to do my test point. And mentally, I'm sticking 0 in for x right here and 0 in for y. And I'll get the statement that 0 is less than 6. And that is a true statement. So I'll shade the side of the red line where 0 is. And there you can see my solution set is the green area. And of course, that green area really comes on down to here, right? And it goes up there, and it continues on forever in that triangular sort of pattern, right? Okay, very good. Now, for the new stuff tonight, how would this be different if I had a system of equations? Okay. In fact, let me use the same exact equations so that I don't take super long to do this. Hold on one moment. Okay, so I have my equations, except I need to turn them into equations. So I'll make this y equals, and then of course this part here would be less than equals 6 instead of less than 6. All right, I'll plot the red one first, and notice that I will get the same x and y intercepts. Right, and then I'll go, oh, I've got those backwards, don't I? I think it's 3, 0, and 2, 3, or 0, 2. Yeah, there we go. Sorry about that. Okay, so I'm going to go up 2 and back 1, 2, 3. Right? Good. Those do look linear. And now it'll have to be a solid line because it is equal to 1, 2, 1, 2, 3. Okay. And get an arrowhead on there, make it a little thinner. There we go. Okay, make it a little more precise. Okay, now with the black one, I've got up 5, 1, 2, 3, 4, 5. That was my y-intercept, and a slope of 1/2, right? Down 1, back 2, down 1, back 2, and I'm ready to draw. And what I do is I go ahead and graph the line, just like normal. And again, I'll do my arrowheads, and there we go. Now, this is kind of a weird situation because when we're solving a system, we're finding out the place where the lines cross. With a system of inequalities, we actually find an entire region. We find a whole bunch of points, way more than a Google's worth, that make both inequalities true at the same time. Okay? You realize this black line here, this black line, its equation. The line is all the solutions because there isn't just one. If we had a simple equation just like this, x plus 5 equals 8, you could all tell me that x equals 3, right? But because we have two variables in here, there is no one right answer to this. If I make a t-table, I could theoretically make that t-table forever and keep finding more and more solutions to this. For example, when x is 0, y is 5. But when x is 2, y is 6. When x is 4, y is 7. And it keeps going on like that forever. And don't forget all the points in between. I could check when x is 1, or x is 1.5, or x is 1 3/10, or x is 1.45629358716, repeating. Okay? There's an infinite number of solutions. When I have a system of equations, I'm finding the place where the lines cross, where the red line and the black line, or their equations, have the same answer. Meaning if I knew that x value there, right there inside there, I'd plug it into both equations, 1 and 2, and then I would solve for y, and I'd get the same y out. The problem with solving systems of equations by graphing is just this. Looking at this picture, you can't tell me exactly what the x value is. You can estimate, maybe it's like a negative 2 8/10, maybe, but how do you know it's not negative 2.81357? How do you know? You don't. And so solving a system graphically can be a great thing to do, and sometimes it works really well. We'll do some application problems right after the break that graphing is a great way to do it. But sometimes it's not a great way because you can't tell where they cross. All right, keep that in mind. We're going to do one more problem here where we're going to solve the system. And actually, I hope you're going to try it on your own because solving a system of equations should be simple. Should be a simple thing to do, especially if you can solve the systems of inequalities. All right, so let's say we have this equation. Let's go with y equals negative 1/3 x plus 4. And then let's go with, hold on 1 minute. Okay, so here are my two equations. I'm going to go ahead and graph the blue one first. I know it's in slope y-intercept form, so I go up 1, 2, 3, 4. All right, then I go down 1, right 3. Down 1, right 3. Oops, 3. Yeah. Okay, it's going to be a solid line because it is an equation. It is equal to. And I draw it in there. And I put an arrowhead on it. And there we go. The red one is in standard form. I'll use my shortcuts. I see right off the bat that the y-intercept is going to be pretty easy to find. I think the y-intercept is going to be 0, 4. I did c divided by b. So I'm going to go up 1, 2, 3, 4 right there. And then my slope is -5 over +3. Do you notice I didn't try to find the x-intercept? Because I looked ahead and I saw that 5 doesn't go into 12 evenly, but 3 goes into 12 evenly. So I went for the y-intercept and then the slope, because now from here I can just go down 5, 1, 2, 3, 4, 5, right, 1, 2, 3. Right, up 1, 2, 3, 4, 5, back 1, 2, 3. All right. Again, it's going to be a solid line. Okay, 1, 2, 3, 4, 5, 1, 2, 3. And it should be pretty obvious. Turn it into an actual line and not an array here. There's got to be a way to change this default setting. I'm just not sure how to do it. Brendan Lovejoy can probably figure it out for me. All right. It's pretty obvious that the lines cross right there at 0, 4. So the solution to this system is 0, 4. So we looked at the first one where we couldn't tell where the solution was. All we could do was circle it on the graph. But on this graph, both lines go through the point 0, 4. Okay, so what do we do in a situation where the graph might not work? Well, there's other ways to solve. And the first way we're going to learn is called solving by substitution. And you guys have been using substitution for a long, long time. You just don't know you've been doing it. For example, if I gave you this equation, x plus 7 equals blank, tell me what that is when x equals 2. Well, you'd say, well, okay, this is going to be 2 plus 7, and that, of course, will equal 9, right? What you did was you substituted 2 in x's place because x and 2 have equal value, so they can be put in each other's places. All right, well, how does that look when we have two equations? Say like y equals 2x plus 4, and then y equals, let's go with 3x plus 8. Okay, now check this out. This is pretty slick. It's actually super easy. Don't let it freak you out. What's 2x plus 4 equal to? Hopefully you're shouting at your computer that it's equal to y. What's 3x plus 8 equal to? It's also equal to y. If 2x plus 4 is equal to y and 3x plus 8 is equal to y, isn't it true that 2x plus 4 must be the same as 3x plus 8? Isn't that a true statement? I mean, if y stays the same, 2x plus 4 is equal to some number, 3x plus 8 is equal to that same number, then these two statements here must be equal to each other. That's substitution. All right? Now, it's a multi-step equation. I think I will subtract 2x from each side. And while I'm at it, I'm going to skip a step and go ahead and subtract 8 from each side. I'm going to get my x's on the right-hand side of the equation, my constants on the left-hand side, and that will work out pretty. X will equal -4. So if I were to graph these two lines, the place they intersect would have an x coordinate of -4. That's what I'm finding out. But I'm doing it without graphing. Now I need the y coordinate. I'll bet you James Bollinger knows how to find the y coordinate. He's going to say, Mr. Lawrence, since we know that x is the same as -4, I can take this -4 and I can plug it into either equation. I can put it in there for x, or I could put it in there for x. I'm going to choose the top equation because the numbers are a little bit smaller, might make the math a little bit simpler. Hold on, everything just disappeared there. And I'm going to plug it in. So I'm going to write y equals 2 in parentheses. I love to use parentheses when I substitute things in. Negative 4, put it in x's place, and then I'm going to add 4 to it. And I'm going to go ahead and solve for y. Y is going to equal negative 8 plus 4, and therefore y is going to equal negative 4. So that means these two lines are going to cross at the point negative 4, negative 4. Kind of a coinky-dink there, but it can happen. Not a problem with that. It's bothering me that they crossed right there, but I'm just going to check my work really quick. Yeah, I've got a mistake somewhere. Hold on one second. Let me see if I can find it. No, actually, I think I'm good. Okay. Just wanted to make sure that that we were doing it right. Let's look at another one. Let's look at one like this. Let's say we have, this one might turn out ugly. I'm just going to make it up. 5x plus y equals 7. And 3x plus 4y equals 9. Okay. Now, this one isn't quite so simple because we don't know, we don't have a variable alone. But in this top equation, you see that the y is almost alone. The only thing keeping it from being alone is this 5x. If I would subtract 5x from each side, I could change the way that top equation looked. I could subtract 5x from both sides. Let me write down my work here for those of you that have a little trouble following it. I will subtract 5x from both sides, and I will get y equal to negative 5x plus 7. If you were thinking that you'd get like 2x or something there, please go home and boil some noodles and then beat yourself with them after they're thoroughly boiled. Remember, you can't combine unlike terms. We don't want to make any banapples, right? You can't combine the 7 and the negative 5x because they're not like terms. One's an x term and one is not. You can't put them together. So there's my new equation. Now I know what y is equal to. Well, if I know that y is the same as negative 5 plus 7, I can take this equation here. All right? I can take that equation there, and I'm going to rewrite it. 3x plus 4. Start a parenthesis. What do you think I'm going to put in the parentheses? That's right, I'm going to substitute in what y is equal to. Negative 5x plus 7. I'm going to substitute it right in there. Oh, I think I want to be in black. So I'm going to get negative 5x plus 7, right? And that will have to equal 9. What did I do? I substituted in. I got one of the variables alone in one of the equations. I chose the one with the easiest math, and then I substituted into the other equation. All right. So now I go to simplify the left-hand side. So the first thing I'm going to do is distribute. Okay, 3x minus 20x plus 28. That needs to equal 9. And then I'll combine like terms on the left-hand side. I notice that I have a positive 3x and a negative 20x. Combining those will get me a negative 17x plus 28 equals 9. All right, I'll go ahead and solve listening to Saddam. And we got negative 17x equals, I think that's going to be a negative 19, right? Negative 19. Oops, that's okay. Yeah, that's right. And then I still need to get x alone. So I'll divide by negative 17, and I'll get x equals 19/17, or 1 2/17. Those are kind of ugly numbers to work with. So I might go ahead and use a decimal in this case because 2/17 just is an ugly fraction. And I know that it's going to be about approximately, wait, I got to get back in right mode, 1.12. That's close enough. We'll go to the hundredths place. Now, of course, that will affect my answer a little bit because I rounded. It's like 0.1176, and the thing goes on for a little bit longer than that. So it's going to affect my answer, but that is my x value, okay? To get my y value, I'm going to pick any one of these equations, and I'll highlight them in green to show you which equations I can use, because sometimes kids do this the hard way. I could use this original equation right here. I could use this original equation, but I could also use this equation here, because this one, the last one I highlighted right here, is the same equation as that one, just in a different form, right? And y is already alone, so I think it would be easier to use that equation. So what is it? Negative 5x plus 7. So I'm going to use y equals negative 5x plus 7. I'm going to rewrite it, but wherever I see an x, I'm going to take this 1.12, this rounded answer, and I'm going to put it in x's place. So my new equation will be y equals negative 5 times the quantity of 1.12, 1 and 12 hundredths, plus 7. All right, so let me see here, give myself a little room to work. I need to multiply, so I'm going to get y is equal, and let's see, that's going to be a 0, and I'm going to carry the 1, and then I'm going to get a 6. And that's not going to carry, and then a negative 5, I believe, plus 7. Now, some kids struggle with this. This is super easy. If I had $7 and I owed you $5, I gave you your money, I'd give you, I'd still have $2, right? Okay, but I actually owe you $5.60. So from that $2, I have to take away another 60 cents. Oh, that means I'll have $1.40 left. So the place of intersection for these 2 points is 1 and 12 100ths for the x-coordinate, and the y-coordinate is 1 and you could say as simply as 4/10, or you could say 40 100ths. Since I went to the hundredths place, I will go to the hundredths place again. Okay, that's how you do it. I'm going to give you 1 or 2 practice problems here. Let's make it 2. You can try them on your own, and then go ahead and see the answers. So let's review really quick before we try them. Step 1, get one variable alone in one of the equations. It doesn't matter if you solve for x in the first equation, y in the first equation, x in the second equation, or y in the second equation. Pick the one that makes the least amount of work. Okay? Step 2, substitute. Okay? Step 3, that's where you solve for one of the variables. And it all depends, because if you solve for x in this equation, when you plug it in, you're going to be solving for y. Okay? So it'll be the opposite, but you'll know because there won't be x's in the equation. That doesn't look like the word solve, does it? Solve. Okay? And then step 4, you substitute again to find the still unknown variable. And your answer, your solution, if there is a solution, will end up being an ordered pair x, y. Okay, so hold on a second. Let me get a couple problems here. Okay, there are your two practice problems. Go ahead and give them a shot. When you're ready, you'll see the solutions pop up. Okay, here's my solution for the red one. It's not 100% complete. You can see y was already alone. Oops, y was already alone. So all I did was substitute 3x minus 2 into the second equation for y. And that's shown on this line here. X minus 2 times the quantity of 3x minus 2 and equals 4. All right, I distributed. I combined like terms, getting me to this point. And then I solve for x. I know that x is 0. Now I can choose this equation, either one of those to plug 0 in for x. Since y is already alone in this one, I'm going to go ahead and plug 0 in for x. Some of you can do that in your head. You're going to see that y is going to equal -2. That means these two lines will intersect at the point 0, -2. Okay? All right. I'm going to walk you through this one. Hopefully you've already tried it. It looks like the easiest thing to solve for in this one would be y in the second equation, or in the first equation, excuse me, because it gives everything, I won't have any fractions, everything will be whole numbers. So I'm going to choose to solve for y. It wouldn't be wrong to solve for any of the other variables, but it might be a lot more difficult. So the first thing I'm going to do, I've got 4x plus 2y equals 8. I'll subtract 4x from each side. And then 2y equals -4x plus 8. All right. And then I will divide by 2. And then y will equal -2x plus 4. Now that I have solved for y in one of the equations, it's time to substitute. Step 2. I'm going to take this. I'm going to stick it in this equation for y. So I'm going to rewrite that equation. 3x minus 8 times the quantity of -2x plus 4. That will need to equal 1. Okay, so I'm going to distribute to get 3x plus 16x minus 32. That will equal 1. Combine like terms to get 19x minus 32 equals 1. Add 32 to each side to get 19x equals 33. Then x is going to equal 33/19. Oh my goodness, is that ugly? I think I'll use a decimal approximation for that. I know it's going to be like 1 and 16/19, but it is so ugly. Actually, I think it's going to be 14/19. But okay, so x comes out to be approximately 1. Oops, I'm not in right mode. Comes out to be 1.74. And now that I did that, I can go back and find y. How am I going to do that? Well, remember, I could use this equation, I could use that one, or I could use this one. I'm going to use the third one because y is already alone. So I'm going to take y, it's going to equal -2. I'm going to plug in 1.74 in for x, and then I'm going to add 4 to it. And I'll crunch that on my calculator real quick. -2 times 1.74 plus 4, and then y is going to equal 0 and 52/100. So my solution for the second problem is going to be as follows. Okay, that's Mr. Lawrence signing off. Have a great weekend, everybody.